Hi guys! So what I've got here for you today is our review for the second 9 weeks midterm. And this test is going to be on November 14th, which is a Thursday. So don't forget to study for it. And also the next day, the 15th, is when our egg project is due. So you should be almost done with your egg astronaut project. Remember that we're going to be taking them outside on the 15th, and 60% of your grade, or 60 points, is going to be from the handout that you have, and then the other 40 points is going to be from your actual project. And remember that you're not going to fail if your egg does not survive. But if your egg astronaut does survive, you're going to get some bonus points, okay? So make sure that you are working on that, or that you have been working on that, and that it's going to be ready to go on Friday the 15th. Okay, so let me go ahead and dive right into our review, which is going to be energy, force, and speed. That's what's going to be on our test on Thursday. To start off with, energy is the ability to do work. Okay, so I'm going to write that at the top. To do work. And then remember that potential energy is going to be stored energy. I'm going to write stored. And then kinetic energy is going to be energy of movement or motion. So anytime anything is moving, it's got kinetic energy. Also, mechanical energy is something else that we could say instead of that, a synonym for that. And then potential energy is going to be stored energy. So the picture here says, label the following locations on the roller coaster diagram below. Where am I going to have the greatest potential energy? Well, it's going to be where I have the highest hill, right? So instead of writing all the words, I'm going to just write number 18 here, is at the very top. The least potential energy, I'm going to have potential energy all throughout pretty much, but I'm not going to have very much wherever I'm going to have a lot of kinetic energy. So down here at number 19, I'm going to have very little potential energy, but I'll also have some potential energy down here, or up here on the second hill. It's just not as much as I'm going to have at the top of the hill for number 18. The greatest kinetic energy is going to be down here at the bottom of the hill. So this is number 20 right here. That's where I'm going to be going the fastest. The least kinetic energy is going to be when I'm going up the hill, or where I have lots of potential energy. So I could also have very little kinetic energy way at the beginning over here. And then number 22, equal potential and kinetic energy, is going to be right in the middle of your fall. So 22 would be right here in the middle of my hill, okay? It could also be over here, in the middle of me coming down from this hill as well. Matching. So here you need to know the difference between the different kinds of energy, because you're going to have to figure out energy transformation. So let's dive right into this. Chemical energy is going to be energy stored in the bonds of molecules. So that's letter D. Then I have the law of conservation of energy is going to be I. Energy cannot be created or destroyed, but it can transform into other forms of energy. So remember, it's not magical. It doesn't just appear or disappear. It's just changing into a different form, which we will talk a little bit about in a little while. Then I have mechanical energy, which is energy of motion or position. Mechanical is also going to be kinetic energy. Then I have radiant energy, which is energy of light. And then electrical energy is going to be letter E, moving electrons or electrical charges. Thermal energy is heat energy, so it's letter G. Then 7 is sound energy, which is going to be all about vibrations. And then number 8, just the definition of energy, which we talked about, the ability to do work or cause change also. And then number 9 is nuclear energy, letter F, which is locked in the nucleus of an atom. So when the nucleus splits, it releases energy there. The next part is a little bit more about potential and kinetic energy, and you just have to write a P or a K. I'm not going to go through all of these, but you do have to finish them on your own. I'm just going to point out a couple. A fast-moving river is going to be kinetic energy because it's moving. Number 7, holding a stretched rubber band. I'm just holding it stretched. It's not moving yet, but when I let it go, it's going to move, right? So that's potential energy. Then we have some transformations here, and I'm just going to do a couple of these with you. Electrical to mechanical, that means I probably plugged something in and now it's moving, and a good example of that would be a fan. Number 8, chemical to electrical to sound. So chemical is going to be in the bonds, that changes it to electrical, that changes it to sound, and that's going to be an MP3 player or anything that makes music. It can even be your phone, right? Chemical, because of the battery, and then there's electrical, it turns it into electrical, and there's wires and stuff that are transferring that electrical energy, and then it actually plays the sound for you. So go ahead and finish the rest of these on your own. And let's go on to conduction, convection, and radiation. So conduction, remember, is going to be touch. So anytime heat transfers because something is touching something else, a pot on a burner is a really good example of conduction. Okay, then convections have to do with currents and mixing. And it's all because of density, right? When something is less dense, it floats, like hot stuff is less dense. So a really good example of convection is this hot air balloon. Convection. Okay. Then radiation is traveling through space. It's not traveling through anything. So it could be like the sun heating Earth or a light bulb. This is a good example of radiation right here. Because it's giving off heat. Roasting a marshmallow, the fire, right, would also be doing that. So lots of examples of radiation there. So go ahead and finish off the rest of these on your own, please. And then we have force. A force is a push or a pull. It's going to be anything that can put matter in motion is going to be considered a force. So we're going to mark these with B's and U's for balanced and unbalanced, and I'm just going to do a couple of them. Pushing a file cabinet across the room, I'm changing the motion there, so that's going to be unbalanced, okay? And then number 29, arm wrestling, but nobody wins, so basically they're stuck there. Their strengths are matched, and so that's going to be a balanced force, okay? This could also be if something's already in motion and it just keeps going, that's still going to be a balanced force. But if something's in motion and then it changes motion, like it turns or something, then that's going to be unbalanced as well. Then we've got net force. So here for the top boxes, you need to mark it as balanced or unbalanced, and then give the net force and tell me what direction it's going to move in. So we're going to do the little bear together. So here I'm going to add these two because they are working together. And here this is 23 going in this direction. And so then if I look at the 23 and the 22 right here, they're working against each other. So I have to do 23 minus 22 is equal to 1 Newton of net force. So that's going to be unbalanced. And then which one is going to win? Well, the 23 is going to win, so it's going to move in that direction. Okay, finish off the other ones. Remember, add up the arrows that are going to be working together first, and then look at the ones that are going to be working against those. So if they're working together, you add them, and if they're working against each other, you subtract them. Speed. Here we have 4 problems for speed. You're going to write your answer at the very top. We're going to do number 11 together. A car traveled 240 kilometers in 5 hours. So remember, speed is equal to distance divided by time. So here I've got 240 kilometers divided by 5 hours. So if I do 240 divided by 5, I end up with 48 kilometers per hour. No naked numbers, so please do not forget your unit. And then at the end of this, it says to circle the one that has the object that is traveling with the fastest average speed. So finish off the other 3 of these, and then circle the one that is the fastest. Here we have some distance time graphs. And I'm not going to go through all of these questions with you, although you have to do them on your own. There's just a few that I want to talk about. And on this slide, I want to talk about number 18. Calculate the average speed at 5 hours. So notice what I have here on my y-axis. I've got distance on my y-axis, and then of course I have time on my x-axis. So if I calculate my average speed at 5 hours, I have 5 right here. I go up here and I look at my dot, and my distance is 100. So I'm going to do 100 divided by 5, okay? And that's going to give me my answer of 20, and my unit is kilometers per hour, okay? So whenever it talks about average speed, go to either the time it tells you, right, or the very end, and that's going to give you your average speed. Here is another example, and there's a bunch that I want to talk about on here, so I'm going to circle them. I want to talk about 18, 19, 20, 21, 22, and 23. You still have to answer number 16 and number 17, okay? But I want to talk about these. So number 18, which object traveled at a greater speed? Explain your answer. So look at line A and line B. And remember, when a line is straight like this, that means that it's at a constant speed. That means it went the same speed the entire trip. And if the slope is steeper, like here, A is steeper than B, then I know that that one went faster. So if you think of it like winning the race, who's going to get there first, right? Well, A is going to get there first. He or she was going faster. So that's how I know that A was at a higher speed, because it's a steeper slope. Number 19, calculate the average speed of object A. So again, look at the time, look at the distance at this point right here for number 19. Same thing with number 20, calculate the average speed. So you look at this point right here, get your time and get your distance and divide, or different distance divided by time, right? Number 21 and number 22, I just wanted to talk about really quick because I didn't want you to get confused. Number 21, what is the interval for distance? That means, what are they going by? And so here they're going by 30s, okay? And then 22, what's the interval for time? What are they going by here? They're going by ones, 1 second. And then number 23, draw a new line on the graph to show an object accelerating. Label the line C. So remember, when we're talking about acceleration, we're talking about something getting faster, right? Or getting slower. So I'm going to draw one that's showing an object getting faster. Let's curve up. Okay, and so I'm going to label this as faster. It's getting faster and faster. And then I'm going to draw one that's getting slower. These are both going to be considered acceleration. So this one is getting slower. And you could tell that because if you look at my blue one, eventually it's going to get so slow that the line becomes horizontal. And if you look at this, like this line that I'm about to draw, it's let me get a darker color. This is a horizontal line. Sorry, my line is kind of crooked. But when I have a horizontal line like this, that means that I've totally stopped. Time is passing, right, as I go this way, but my distance is not changing, and so I've totally stopped. That means that I am at rest, okay? So that's your review for the second 9 weeks. Please study. If you have any questions, let me know, and I will see you guys at school, okay? Thanks for watching.